Alright, so this is video 9.1. It's going to be real quick. It's just over vertical asymptotes and how we find those. We talked about this a little bit in class, but instead of there just being one x, in a lot of ours, there'll be multiple. So we need to cover some more complicated stuff. Not that it's overly complicated, but more complicated than the couple examples we've already done. So vertical asymptote. In class, we discussed vertical asymptote happens on our graph because in math, we're not allowed to divide by 0. So since we're not allowed to divide by 0, any x value that I plug in to these equations, these are 3 different examples, any x value that I plug in that makes me divide by 0 or gives me 0 in the denominator can't happen. And the x values that can't happen, we're going to call vertical asymptotes. We're going to learn a different word in the future that may counteract this. But for now, any x value, the way I have it structured, that gives us 0 in the denominator is going to be called a vertical asymptote. So, we've got x plus 3. Any x value that gives me 0, that forces the denominator to be 0, cannot happen. So if x plus 3 is the denominator, then x equals negative 3 is my vertical asymptote. It's that easy. We cannot have 0 in the denominator. So any value that gives me 0 will turn into a vertical asymptote. So that's my vertical asymptote right there. X equals negative 3. On to example 2. So example 2 here is the same thing as example 1, but I have 2 x's in the denominator. I have x plus 1, and I have x minus 9. So because I have 2 x's, I'm going to have 2 separate vertical asymptotes. But to actually find them, it's any x value that gives me 0 on bottom is still the issue that I'm after. So if our x value is negative 1, we have an issue. And if our x value is positive 9, we also have a problem. But both of these are vertical asymptotes, both of them. So this will kind of be a crazy looking graph, and we'll get into what the graph looks like in class. But for now, just know that a vertical asymptote is any x value that causes me to divide by 0. If an x value is plugged into the equation and I divide by 0, we're in trouble. That can't happen. So the last one is as tricky as we're going to get. So if you notice, this says x squared. So anytime we see x squared in this rational unit, which is unit 9 and unit 10, every time we see x squared, we need to immediately be thinking factoring. So every time you see x squared on our next few tests, immediately just factor it. Hopefully just second nature, we see x squared, we factor it. The more we do, the quicker we'll be. So factoring a times c, so that's 12. Write my factors at 12. Kind of get in my own way here, but write my factors at 12. My factors at 12 that add to 8 are 6 and 2. So let's do this real quick. X squared plus 2x plus 6x plus 12. We group our first 2, group our second 2. So we're going to take out what the first parentheses has in common. And if we look, both of these have an x. And when we divide that out, we get x plus 2. The second parentheses, both of them have a 6. When we divide that out, we get x plus 2. My first factor is x plus 2. My second factor, x plus 6. So my denominator was x squared plus 8x plus 12. I just factored it to x plus 2, x plus 6. And I know I have that giant Doceri desktop trial in the way. So hopefully you're listening. But x plus 2, x plus 6, now this just looks exactly like the second example. So if x plus 2 is a factor, then x equals negative 2 is a problem. And if x plus 6 is a factor, then x equals negative 6 is a problem. So this says negative 2, if you can't see over the Doceri desktop trial. That says negative 2. This that I just highlighted down here, that I'm highlighting, says x equals negative 6. So I have two vertical asymptotes again. So my vertical asymptote, I have one at negative 2, and I have one at negative 6. That's vertical asymptote. Any x value that makes me divide by 0 can't happen. So that's a vertical asymptote.